Dear students, this is the fourth lecture of Fourier series. In this lecture, we will take one more example on Fourier series. Often the Fourier series 2 represent fx equal to 1 upon 4 pi minus x whole square in the interval 0 less than x less than 2 pi. Okay, we know that Fourier series is defined by the formula fx is equal to 1 upon 4 pi minus x whole square is equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. Okay, where a0, an and bn are Euler's constants, Euler's coefficient. Okay, now we find out a0, an and bn by using Euler's formula. We have, by the Euler's formula, we have a0 is equal to 1 upon pi 0 to 2 pi f of x dx, that is 1 upon pi 0 to 2 pi, and here fx is equal to 1 upon 4 pi minus x whole square dx, that is, this is 1 upon 4 pi, and what is the integration of this? Minus of pi minus x whole cube upon 3, and limit is 0 to 2 pi, that is minus 1 upon 12 pi, 4 pi into 3, 12 pi, minus is common term, and this is pi minus x whole cube, and limit is 0 to 2 pi. Now we apply this limit, minus 1 upon 12 pi is outside. When we put x equal to 2 pi, it is pi minus 2 pi whole cube, minus when x equal to 0, it is pi minus 0 whole cube, that is 1 upon 12 pi. What we have here? Pi minus 2 pi, that is minus pi to the power 3, and here minus pi to the power 3, that is minus minus plus 2 pi to the power 3 upon 12 pi. On solving this, we have pi square upon 6. This is the value of first Euler coefficient a0. Next we find out an. Formula of an is 1 upon pi 0 to 2 pi fx cos nx dx, that is 1 upon pi 0 to 2 pi. What is fx? 1 upon 4 pi minus x whole square cos nx dx. Now we integrate this. Here 1 upon 4 pi is the common term. Now we have to integrate one by one by integrating by parts. Okay, we can apply, I already told you in my earlier classes. Here we will integrate this integration by parts by using some another technique. Okay, what we will do, how we will integrate. Suppose this is the first function and this is the second function. First function, that is pi minus x whole square, integration of second, integration of cos nx is sin x and nx upon n, minus differentiation of first, that is 2 and pi minus x, 2 pi minus x, and differentiation of this term, we have negative term also, and integration of this term second, integration of second is minus cos nx upon n square, plus differentiation of first. What is the differentiation of first? 2 into minus 1, and integration of second, integration of this cos nx is minus sin nx upon nq, and limit is, next differentiation of this constant term will be 0, means 0 to 2 pi. Okay, this is the integration by parts. Okay, we apply this formula. Suppose we have this function here, u and v are function of x. First function we write as it is, then integration of second, that is, suppose here b1 is representing integration with respect to x, minus differentiation of first, suppose u dash is the differentiation of first, integration of second, integration of this term, plus differentiation of second, first, integration of second, this is, and so on, and I'll taking plus minus alternately. Okay, we apply this formula for getting integration by parts in easy way. Now we simplify this. An is equal to 1 upon 4 pi. Now see, upper limit is 2 pi, and we know that sine, what is the value of sine 2n pi? Sine 2n pi is 0. I already told you in my earlier classes. Sine 2n pi, cos n to sine 2n pi is 0, cos 2n pi is minus 1 to the power n, sin n pi 0, cos n pi 0. We can directly put this value here. When we apply this limit, here whatever we have this value, pi minus 2 pi, but when here we have sine term, means when we put x equal to 2 pi, then this sine 2n pi will be 0, means this first term completely will be 0. Here minus minus plus, here minus minus plus, and again we have minus. So when we put x equal to 2 pi, here we have pi minus 2 pi, that is minus pi. Okay, and minus of cos 2n pi. And what is the value of cos 2n pi? Cos 2n pi is minus 1 to the power 2n, minus 1 to the power even number means plus 1, means here we have minus 1 upon n square. Okay, and here minus minus plus, and this minus sign, sin 2n pi is 0. This is the low upper limit. Now we apply lower limit. Sin 0 is 0 minus, see, when we put x equal to 0, it is when we put x equal to 0, here we have x equal to 0, it is minus 2 pi, minus minus plus, and cos 0 is 1 upon n square, x equal to 0, and again here we have sine term, sine 0 is 0. What we have here? On solving this, n equal to 1 upon 4 pi. This is minus minus plus. This is 2 pi upon n square. This minus and this minus plus 2 pi upon n square. That is n equal to 1 upon 4 pi. 1 upon 4 pi into 4 pi upon n square. These two are cancelled out. That is 1 upon n square. Means n is equal to 1 upon n square. Okay. Now we find out next Euler's coefficient Bn. What is the formula for Bn? Bn is equal to 1 upon pi 0 to 2 pi fx sin nx dx. That is 1 upon pi 0 to 2 pi 1 upon 4 pi minus x whole square and sin nx dx. Now again we integrate by parts, taking pi minus x whole square as a first function and sin nx as a second function. What we get here? 1 upon pi, 4 pi is the common term. First function as it is, that is pi minus x whole square as it is. Integration of second. Integration of second means integration of sin nx is minus cos nx upon n. This first term is positive, second will be negative, minus differentiation of first. Differentiation of this is minus 2 pi minus x, because differentiation x is minus 1, then we have here negative term. And integration of this term. Integration of this term will be minus sin nx upon n square plus differentiation of first term. Differentiation of this means minus 2 into minus 1, and integration of second, that is integration of sin nx is minus cos nx minus minus plus, that is cos nx upon n cube, and limit is 0 to 2 pi. Now we should simplify the negative sign. Here these two will be cancelled out, positive, and these two will be positive. Okay. Now what we have? 1 upon 4 pi. Now first we put upper limit x equal to 2 pi. When we put x equal to 2 pi, what we give here? Pi minus 2 pi. Pi minus 2 pi is minus pi whole square means pi square, and here we have minus common sign upon n and cos 2n pi, and we know that value of cos 2n pi is 1. Here we have 1. First we are putting upper limit, so this is minus pi square, and in next term we have all sine term. When we put sine x equal to 2 pi in sine, mean this term will be 0, and when we multiply this 0 by 0 means this term we have 0, plus 2 into cos 2n pi is 1 upon 1 upon nq minus lower limit. When we put x equal to 0, it will be minus, this minus is common, x equal to 0 means pi square upon n, and cos 0 is 1, sin 0 is 0, this term will be 0, plus 2 minus 2 into 1, and cos 0 is 1 upon nq. That is Bn is equal to 1 upon 4 pi. Here we have one negative term minus pi square upon n plus 2 upon n cube, and here we have plus minus minus plus pi square upon n, and when this minus when multiply here 2 upon n cube means these 4 cancel out. That is Bn is equal to 1 upon 4 pi into 0, that is 0. Okay, what we have? We have value of a0. What we have? a0 equal to pi square upon 6, an is equal to 1 upon n square, and bn is equal to 0. Now from equation 1, fx means 1 upon 4 pi minus x whole square equal to, now here we put values of a0, an and bn. Okay, that is 1 upon 2 a0 is pi square upon 6 plus summation n equal to 1 to infinity an means 1 upon n square cos 1 upon n square cos nx, plus bn is 0 means this term will be, this complete term will be 0. Okay, that is 1 upon 4 pi minus x whole square is equal to pi square upon 12, plus when expand this cos x upon 1 square cos 2x upon 2 square and so on, and this is the final answer. Okay, in this way we can expand this function with the help of Fourier series. Now we will take one more example for Fourier series. Question is obtain a Fourier series for the function fx is equal to x square in minus pi less than equal to x less than equal to plus pi. Then sketch the graph of fx, hence show that one upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus 1 upon 4 square is equal to summation n equal to 1 to infinity 1 upon n square is equal to pi square upon 6. One upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square summation 1 to infinity, sorry, this is equal to pi square upon 12. And third deduction we have 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square is equal to summation n equal to 1 to infinity 1 upon 2n minus 1 whole square is equal to pi square upon 8. Okay, here we have to expand this function. Here fx is equal to x square and interval is minus pi less than equal to x less than equal to plus pi. Okay, here limit is minus pi to plus pi. If limit is minus pi to plus pi, then we have to also check whether this function is an even function or odd function. Okay, if we in starting, if we check this whether the function is an even or odd, then we can directly say that if function is an even function, then bn will be 0. If the function is an odd function, then a0 an will be 0. Then we can directly find out the Fourier series. Okay, since here f minus x is equal to minus x whole square is equal to x square, that is equal to fx. That is, here fx equal to x square is an even function. That is, we can say that bn will be 0. Now what will be our Fourier series? When bn will be 0, fx is equal to x square equal to a0 by 2 plus summation n equal to 1 to infinity n cos nx. Okay, here bn will be 0. That's why we didn't have any sign terms. Okay, now how we will find out a0? Formula of a0 is 1 upon pi minus pi to plus pi f of x dx. Here this is an even function, means this will be 2 upon pi 0 to pi fx means x square dx, and this is 2 upon pi. On integration we get here x cube upon 3 and limit is 0 to pi, that is 2 upon 3 pi into pi cube. Okay, when x equal to 0, the minus 0 term we get here, means here we have 2 upon 3 pi square. Next we find out an. Formula of an is 1 upon pi 2 upon pi 0 to pi x square cos nx dx. Okay, now we integrate by parts, taking x square as a first function and cos nx as a second function, that is 2 upon pi. First function means x square, integration of second, that is sin nx upon n, minus differentiation of first 2x, integration of second, integration of this term is minus cos nx upon n square, plus differentiation of first, that is 2, integration of second, minus sin nx upon, this is n, nx upon n cube, and limit is 0 to pi. Now we apply, first we solve this side. This negative means this negative means positive sign, and here we have negative sign. 2 upon pi is the common term. First we apply upper limit x equal to pi. Okay, so that is x equal to pi means pi square sin n pi. What is the value of sin n pi? Sin n pi is 0, means this term will be 0, plus 2 pi cos n pi. Cos n pi means minus 1 to the power n. Cos n pi is minus 1 to the power n upon n square. Again we have sin term, means sin n pi again 0, minus lower limit x equal to 0, x into this 0, plus x into this 0, 0 into 0, 0 into 1 means 0, minus sin 0 is 0. Okay, what we get here? This is equal to 2 upon pi into this term is also 0, 2 pi, and this is minus 1 to the power n upon n square. Okay, this pi is cancel out. What we get here? An is equal to 4 into minus 1 to the power n upon n square. Okay, now what we have? Value of a0 is 2 upon 3 pi square, and value of an is 4 into minus 1 to the power n upon n square. Okay, now from equation 1, we substitute the value of a0 and an. We get here x square, a0 by 2, that is 1 upon 2 into 2 upon 3 pi square, plus summation n equal to 1 to infinity an, means 4 minus 1 to the power n upon n square cos nx. Okay, that is x square equal to, this is cancel out, and we have here pi square upon 3. Okay, plus 4 into summation n equal to 1 to infinity minus 1 to the power n square cos nx, minus 1 to the power n square cos nx. Okay, now we open this. Now we put here and 0 1 2 3. Okay, what we get here when we put x equal to 0 1 2 3, n equal to 1 2 3, means x square is equal to pi square upon 3. Minus 4 is the common term, and here we have cos, when we put n equal to 1, cos x upon 1 square minus cos 2x upon 2 square plus cos 3x upon 3 square minus cos 4x upon 4 square and so on. Okay, suppose this is the equation number 1, and graph of this function will be, we can also draw the graph. Here this is x-axis, this is y-axis, this is x-dash, this is y-axis. It is here function is y equal to fx is equal to x square. Here x square is equal to y is a parabola of this type. This is a parabola of this type, and here this point is suppose minus pi, and suppose here this point is plus pi. Okay, this is the origin, this is the graph of this function. Now we have to deduce following terms 1, 2, 3. Okay, these are the deductions we will find out with the help of equation 2. Now putting x equal to pi in equation 2. When we put x equal to pi, here this will be pi square, and this is transformed here, pi square upon 3 is equal to minus 4. Now cos pi is minus 1, that is minus 1 upon 1 square. Okay, cos 2 pi is plus 1, that is 1 upon 2 square minus 1 upon 3 square minus 1 upon 4 square and so on. That is, on solving this, that is 2 upon 3 pi square is equal to 4, 1 upon 1 square plus 1 upon 2 square plus 1 upon, this is 3 square, 1 upon 3 square plus 1 upon, that is 1 upon 1 square plus 1 upon 3 square plus 1 upon 4 square. We transform this term here. What do we get? Here we get pi square upon 6. This is the first result. Means we can say equation number 3. Okay. Now we put x equal to 0 in equation 2 for getting second deduction. When we put x equal to 0, it is 0 equal to pi square upon 3 minus 4. Here cos 0, that is 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square and so on. That is 1 upon 1 square minus 1 upon 2 square. We transform this here, plus 1 upon 3 square minus 1 upon 4 square is equal to pi square upon 12. Okay, suppose this is the equation number 4. Now third result is 1 upon 1 square, and we can write this pi square 1 upon 1 square means 1 upon n square. Also we can write it, this is equal to summation n equal to 1 to infinity 1 upon n square also. Okay, now we have to deduce third result, 1 upon 1 square plus 1 upon 3 square plus, if we add these two, then we can find out this result. Now adding equation 3 and 4, adding equation 3 and equation 4. Now when we add equation 3 and 4, what do we get here? When we add, this term will be cancelled out, 1 upon 2 square. These two will be cancelled out, these two will be cancelled out. What we get here? We get 2 times 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square is equal to, here we have pi square upon 6 and here we have pi square upon 12. Okay, that is 2 times 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square is equal to 12 LCM 2 pi square plus pi square, that is 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square is equal to 3 pi square upon 2 into 12 that is 3 1 3 4 ja, that is 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square is equal to pi square upon 8, or we can also say that summation n equal to 1 to infinity 1 upon 2n minus 1 whole square is equal to pi square upon 8. I think this method is clear to all of you. If you have any queries regarding this lecture, you can comment on comment box, and if you feel this lecture is helpful for you, then please like this video and subscribe this channel, and you can also press bell icon for getting notifications about my lectures. Okay, thank you very much. Have a nice day and Bharat Mata ki Jai.